Hello, 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 hello.
Good morning, everyone, and greetings from Yashwantrao Chauhan Institute of Science, Satara. We all have gathered here today for the international webinar on technological trends in mathematics and statistics. To begin with, I request Dr. D.R. Hasbe, Head Department of Mathematics and the PG Dean of our institute, to welcome and introduce the speakers to the audience. Dr. D.R. Hasbe.
शिक्षण संस्थास यशवंतराव चव्हाण Institute of Science, Satara, Department of Mathematics and Department of Statistics organized international webinar on technological trends in mathematics and statistics. I feel honored to welcome Honorable Principal Dr. B.T. Jadhav sir, President of this program, Honorable Vice Principal Dr. V.Y. Deshpande, and co-convener of this program webinar, Dr. H.P. Uma. Today's resource persons, Mr. Swapnil Hasbe and Dr. Sachin Kumar Bhalekar, and all participants for taking a keen part in this webinar. I am sure that you all feel enriched with knowledge after completion of webinar. I would like to introduce our today's resource persons, Mr. Swapnil Hasbe and Dr. Sachin Kumar Bhalekar. First, resource person Mr. Swapnil Hasbe is alumni of our institute. He pursued his bachelor in computer engineering at Siagar College of Engineering, Pune, and master's in computer science from University of Texas at Dallas, USA. He is currently working in USA as a software engineer. His area of expertise includes applications development, big data, and software engineering. Now, second resource person, Dr. Sachin Kumar Bhalekar. He is working as Associate Professor, School of Mathematics and Statistics, University of Hyderabad. He is a good researcher as well as good academician. His research area includes dynamical systems and fractional differential equations. He has published more than 50 research papers in renowned international research journal. He was awarded Padma Shri late N.S. Venkatesan Gold Medal and A.M. Mithai Research Excellence Award for his research works. I welcome you all once again to the webinar and hope that you all will have a great time ahead. Thank you all.
Thank you, sir, for the introduction of the resource persons to the audience. And now may I request the principal of our institute, Dr. B.T. Jadhav, sir, to inaugurate the session and provide his guiding words to all of us. Honorable Principal, Dr. B.T. Jadhav.
Thank you, Am. Friends, on behalf of Yashwantrao Institute of Science, Satara, it gives me a great pleasure to inaugurate this very good activity organized by the Department of Mathematics and Statistics. Various resource persons and the young and enthusiastic resource persons, Mr. Swapnil Hasbe and Dr. Sachin Kumar Bhalekar. Out of these two, one of is our alumni, and presently he is working in USA. Another one is, as Dr. Hasbe has mentioned, that he is the good academician as well as very good researcher. On behalf of Yeshwantrao Chavan Institute of Science, Satara, Maharashtra, I welcome all the participants, resource persons, delegates, students, and friends. First, I congratulate Head of the Department of Mathematics and Statistics for the organization of such various very good activity, and that activity is in the form of a webinar, so that it is very good to all of us to join virtually via Zoom and various apps through this activity. During the COVID-19 period, world is in the very good difficult condition, and during this complex period, various scientists and doctors are suggesting so many things how to control the COVID-19. I think that during this period, mathematics, statistics, electronics, physics, people also suggest some new concept, new ideas to introduce some new theory as well as some new tools during this period. So Department of Mathematics and Statistics organized that very good activity to motivate the students and researcher in the form of a technological aspects. And the webinar topic is technological trends in mathematics and statistics. This is an international webinar, and students from the various states as well as out of the state from the various countries has participated in this webinar. And on behalf of Yeshwantrao Institute of Science, Satara, as the principal of this college, I declare that the webinar is open. And I just introduce my institute. Yeshwantrao Chavan Institute of Science, Satara is located in Maharashtra. It is a district place. Our institute is autonomous institute. It has the various departments. Some professional courses are there. Strength of the institute, student strength of the institute is 8,500, more than 8,500. We run the computational departments like Bachelor of Computer Science, as well as Bachelor of Computer Science in the form of a software development, animation, forensic science, as well as the biotechnology. We are conducting the undergraduate courses of the biotechnology as well as PG courses. Department of Electronics is with us, as well as we have the various PG courses along 9 streams are with us. And institute is very academic institute. We run the various UG courses, PG courses, as well as we have a very recent topics, and students are doing very well research in the various aspects. Faculty of the institute is very active and enthusiastic. They are regularly interested, taking interest in the research. And we have the CPE as well as various schemes from the UGC, like that DST, DST as well as Star DBT. And we collecting the funds from the various organization and utilizing that funds for the development of the research culture as well as for the construction of the new building. And see that this is a very innovative projects we are organizing for the students. Being as autonomous institute, we have the various new courses, and students are taking interest in the research activities, as well as staff is also taking interest in the research activities. And Department of Mathematics and Statistics is very active department in this institute. And during this COVID-19 period, they have organized the very nice activities. And that activity focus on the new trends in the mathematics as well as in statistics. Statistics, mathematics, electronics, these subjects are very much uh, related with the computer science. And these subjects, statistics and mathematics, are helping for the development of the software. And I think that today's resource persons are very much related to the development of the software and various tools. And through these seminars, we are giving a very good opportunity to the students and researchers. Once again, I welcome all to resource person, participant, delegates, and all the head of the departments, researchers. Once again, I congratulate to the Department of Computer Science and Statistics, and I am thankful to the uh, organization committee uh, for giving me an opportunity to introduce my institute and my views regarding this webinar. Thank you very much.
Thank you, sir, for your encouraging words. Now, we all are aware about the importance of numbers and the equations relating those numbers, that is, mathematics and statistics in our day-to-day life. To throw more light on the applications of mathematics and statistics in technology, we have amongst us Mr. S.D. Hasbe from Innovation Software Developer, Dallas, USA. I request Mr. Hasbe to deliver his talk and guide us on the applications of mathematics and statistics in technology. Mr. S.D. Hasbe. Mr. Hasbe, you are requested to unmute your mic so that we can interact. Please, can you raise your hand if we are audible to you and you are able to communicate properly with us?
Okay. Can you see my video?
Yes.
Yeah, I'm sorry the system was not allowing me to unmute myself, but thank you very much. I was very overwhelmed by the introduction and very good morning over there. And it's always privilege to talk to you, these fellow students, and share the ideas with them. So, and I hope that you guys are doing well in this COVID pandemic situation. So, I've been told to speak on the applications of mathematics and statistics in the technology. So thanks for the opportunity. Thanks to the principal of the college and all the organizing committee for giving me this opportunity to communicate with all the students, researchers, and all the participants. So let me share my screen. And if you have some feedback, sometimes during that call, if you don't get my video or audio, please let me know through the chat. So we'll try to overcome those problems. So in this session, I would like to focus on more on the application side of the mathematics and statistics. in the computer science, software engineering, or and on the other in the other fields like economy, business, education, consulting services. And also, I want to talk about why the mathematics and statistics is important for you. Why should you learn that? And what are the current uh, trending technology that we are already using those statistics and maths concept, and maybe we don't know. So first, let me share my screen. I have made some presentation for you. So give me just a couple of minutes. Okay, are you able to see my screen? Can you see my presentation? Yes. Okay. Um, okay. So I would like to first draw the boundaries for this session, like what we are going to learn from this presentation. So I want to focus, as I before said, that why should we learn the mathematics and statistics? What's the importance that it plays in our day-to-day daily life? As when I was in 11th or 12th, I was always wondering that where can I apply this knowledge, because we study very hard, we study day and night for our exams, we try to get maximum marks in our papers, but we really never think of where we are going to apply this knowledge in our job, right? So that's my first point. The second point, I would like you to realize the application of mathematics and statistics. So especially I'm taking the two separate names because I think that the both methods, both subjects are different. The way they solve any problems in your real life are different. So, and it would be very worthy to know the difference between both subjects. And the third session would be about the question and answer, that if you have questions about how we can pursue our career, or what will be the guidelines that we can follow, and if we have the mathematics and statistics knowledge. So it will be more application oriented. I don't want to cover much of theoretical parts because I know that you have been reading your books all the day and night. So let's go to the next slide. So as I mentioned that I'll start with statistics, then I'll try to cover the difference between the mathematics and statistics. Then we will also see where the mathematics apply, and where the statistics applies, and where they overlap each other. So let's start with the why should we learn statistics. Statistics is a science of learning from data. So what happens is when you have something to predict, so the statistics, what it does is it learns from the data, it analyzes the data based on the different points, based on the different guidelines, based on the different criteria, and it tries to get insights from that data. And what happens is when it goes into the testing phase, like when we get that, let's say we have something insightful data and we try to test it, then we again find the errors, and maybe something is not accurate. So we try to again redefine that data, and we try to get more and more accurate model or accurate results out of it. So the statistic is, I would say, the logic of uncertainty. Whenever there is an error or uncertainty, so statistics is the key for it. And you see in your real life scenarios, whether you go to the traffic or whenever you try to solve your life problems, there is always probability and the risk, and a lack of uh, accuracy. So that's where the statistic plays a role, and we're gonna learn about it more. So I just try to put some examples that you know already, but it might be possible that you don't know how the statistics play a role in the weather forecast. So usually I would say that mathematics and statistics go hand in hand, but we should also also know that what's their role in solving any problem. So the self-driving cars, as you know, there are many. I think one of the self-driving car company, Tesla, you might be knowing about it. And robots, obviously, we know that they are trained like they behave like human. They try to do the actions like human. And third one is weather forecast. So we see that when you open the Google app and you try to know the forecast for next couple of days or next week, and then sometimes we find that um, the application shows that it's gonna be raining, but that doesn't happen. So why doesn't that happen? And it is also possible that for whole week you get the very accurate results. So we're going to learn about that and also know about how the statistics and mathematics plays role behind those events. So as I mentioned, the self-driving car, right? So how does it senses the objects? How does it know that I have to take a turn right or turn left? How does it know the where are the traffic lights? How does it know that it is green, red, or yellow? How does it know that something is walking on the street and we have to stop the vehicle? How does it know that what are the probable actions by the other drivers? So these things are uh, all depends on the data. So the how do we gather that data? So as you know that you have the front camera and the rear camera for your vehicle. So nowadays, like all the uh, self-driving cars, I would say they have the sensors all over their vehicle body, and they get the information from every side, and they try to define the objects. They try to define their properties, and that's why they can define whether it is signal, whether it is person, whether it is a big vehicle, medium size level vehicle. And of course there might be some errors, and there might be some inaccuracy, I would say, but that's how it learns from the statistical models. What happens is, so they it works on the assumption. So even though it is mathematics or the statistics, they assume something. Then after that, they define the properties for that object. And when we have several objects, that based on the properties, they try to categorize each object into the uh, each object into the certain group. So what are the people? What does it mean by people? What does it mean by vehicle, signal, or road? So, and then they try to define their model. And when we get the insightful data, that's how that car takes a right whenever you want, takes left, and it performs the action that the human want, whatever the human want. So when you set any route, let's see from the Satara to Pune, that car knows like what route to follow, where to stop, and where to go. So behind the scene, all these are the statistics model gathered the data from the car sensors. They try to make the models and then get the insights. So when the car is in the testing phase, they try to measure the errors and the accuracy of the results. And when they find that there are some errors and inaccuracy, then they redefine that data. It goes through again the same phase and get the more accurate data for it. So this is my favorite slide. I would say that the mathematics versus statistics. Um, I wanted to cover that because most of the students or people get confused about the statistic is a branch of mathematics where they overlap each other, where they are separate, what's the actual difference. So this is my personal opinion. Everybody can have their opinion based on their experience. So I think that the mathematics and statistics are fundamentally different modes of thinking. That means that if they have some problem, they have different methods to resolve that problem. So as we know that math always follow consistent definition, theorem, proof structure. What does it mean by, like, when you assume something and when you try to define their properties? So let's take an example of triangle, that you know that it has three vertices and three edges, and you try to define their definition of triangle by defining what does it mean by edges, and then you gather all the properties, and by the proof of contradiction or induction you prove that this object is basically triangle or square. So, and if it does not follow those properties, then you prove by contradiction that these are properties are not getting satisfied, so that this object cannot be called triangle. So this is how math follows. And even if you take the examples of E is equal to mc square or Newton laws, so it has, so you can prove any formula based on those proper formula, or if you have given any scenario, you can apply those formula, and uh, if their properties belong to whatever the formula has stated, then you can prove that you can solve this problem by using that formula. And in the statistics, it's common to define the things with the intuition and example. So you know it when you see it. So what does that mean? That means that statistic doesn't have the deterministic approach at the first time. So unlike mathematics, it tries to define any object with some intuition. Then they try to analyze that object and try to get insightful data or results from that object. And then when you know it and when you see it, you know it when you see it, what does that mean? Is whenever let's say you're using your vehicle, right, and if you have sensors all over your vehicle, and when it takes right whenever you want, that means it is aligning with your whatever your expectation is, but is going if it is turning to the left instead of right, so that means you're going wrong. So what you have to do is that means that there is some problem with your statistical uh, model. So in statistic, you always try to get better at your results by trying to redefining your models, and trying to add different parameters based on your previous experience. So that's how the statistic works. So for example, in statistics, you have a graph where you have some parameter on the or variables on the x-axis and variables on the y-axis, right? And you try to put the dots on the graph based on your observation. And there is always the first step involved is to remove the outliers or remove the noise. So in terms of real world scenario, let's see if you have data about anything. Let's see if you have data about the product consumption versus the cost. So based on your observation, you try to put the dots on the graph, and you try to make a line where you can prove that at what point, if the product, if the price increases, the production consumption start decreasing. So that point, it helps to derive the cost of the product. And so so that's very difficult. That's what I'm saying, that when we say that you know it when you see it, it's like there is no universal criteria to define the outliers, or we can say the noise of the data, which data is unwanted or unnecessary that we can get rid of. That is, for that we don't have the universal procedure in the statistics. But whereas in math, you have certain formulas, and you will eventually either you prove correct or not correct. But statistic, there is always getting better based on your previous experience. So these are the different approaches, and they get and they applies their statistic and mathematics. They get applied in a certain situation based on their properties. So you have models that only work in certain assumptions are satisfied, But you see, there is no universal procedure that can you tell whether your data satisfies this assumption. And as I said earlier, that math is logic of certainty. That means that you already have some assumption and you stick with those assumptions. Then you define the properties and then you prove whether it aligns with those properties or not. And in the statistic is the logic of uncertainty, where based on the data you try to make a model, you try to get insight, you analyze that data, you try to get insights of that data, and then you try to correct it by maybe adding different parameters, removing the multiple parameters, etc. So for example, if it is a election survey, so you would see that every channel would have different result for that. Some might say that this party will win and this party will get 60% of the votes, 40% of the votes. There will be always mismatch. So what does that mean? That means that they have different statistical models. So some people focus on certain parameters. They think that these parameters are important and the other parameters are outliers. So if we focus on this parameter, I think our results will be, we can predict better. So that's why every channel will have different approach and different results for it. So how much time we have? Okay. Let me know when the time is up. Uh, yeah. So yeah, I'll try to get to the next slide. So weather forecast, as I already explained, that also gets derived from the different statistical models. So if you follow the different applications for providing the weather forecast, you will always see there will be certain or slightly difference between their excuse me between their results. So that's that's what I said, that in statistics you learn from the data. You always get better at the accuracy. The surveys I already mentioned, and the industries and business decision making. So how the statistics gets applied into those decisions. So if you see, there is always correlation between the price of that product and the consumption of the product. So if the product has price in certain range, you will see that that product gets sold at in large extent. But as soon as it start crossing certain range, you will see that the product consumption will get decreased. So as a business committee, you see, so to defining the price of the product, they always draw a graph, and they see they collect the data for the previous years, and they plot a graph based on that data. And something goes wrong if they realize that in this year we thought that the our price of the product should be, let's say, 50 rupees, right? And at the end of year, if they start realizing the decrease in the product consumption, that means that the price is getting higher. So then they can get accurate at the pricing, they can lower their price, then they again collect the data and see that if their expectations are met or not. So likewise in the agriculture, um, in the agriculture domain also there is a crops management, and also the how much chemicals we need to get the our returns. So that is also based on the statistical models. So this is a linear regression in statistics. So I wanted to use it as an example. So you see, this is on the x-axis you have the independent variable, and on the y-axis you have dependent variable, right? So what it means by, so in linear regression, if that independent variable grows with the dependent variables, it's called as a positive relation. And if independent variable decreases and this dependent if your independent variable increases with decrease in the dependent variables, that's called the negative relationship. And these dots are basically your observations with your x and y values. So for instance, so this is a, let's assume the time on Facebook is a dependent variable and grades as an independent variable. So you see, if if you spend more time on Facebook, if that results in decrease the grades, that means you're getting the negative relationship. So that means it is evident that you have to minimize your time on the Facebook to increase your grades. So this is one example, and this the positive relationship where you can define your dependent variable as um, study and independent variable as a grade. So as you study more, and if you're getting the more grades, that means it is a positive relationship. And the same concept applies to derive the price of the product. So whenever your uh, price goes up, and if your production consumption is also goes up, then you should be fine. That is a positive relationship. But your price goes up and your power consumption goes down, that means that your price is not accepted by the customer. So that's the indicator that you should reduce your price so that your power consumption should get increased. So that's how the linear regression helps you to derive the price for your product. So let's come back to let's switch to the mathematics now. I think uh, I hope that I covered the basic concept in statistics and how it is getting utilized in the real world. So now I would like to spend some time talking about the mathematics in computer science, especially. So everyone, I think, so far learned the graph theory. What is the disconnected components? What is connected components? What are the edges? What are the property of graph? But um, I don't know how many of you actually thought about the real-time applications of the graph theory. Maybe it's around you, but you don't know it. So it's good to know like how the graph is being used in the different applications and that we are um, using it right now. So I would like to name Google Maps and Facebook. So these applications use graph heavily, and the underneath we have matrix to provide the different functionalities. So graph can be represented by matrix. That's one type of one type of representing graph. So as you can see, the graph properties involves the connected components, degree, maximum flow, minimum cut concepts. So these are all the theoretical stuff, and you can find out their definition on either Google or your books. But I'm very interested in showing you how does that graph gets applied into the real life. So, so this is a Google map. This diagram shows that you can see the different vertices here. These circles actually represent multiple vertices, and you see that those are get connected by the different edges. So these vertices can be defined as cities or the place. So for instance, like this is a US map, and you see that these are the major cities in the US. You see the Vancouver on the Canada side, then Atlanta, there is New Orleans, Florida here on that side. Excuse me, the Kansas City. So these cities are connected to each other and they form the graph. So what is so if we have, let's say, one city here and that is not connected to any other the vertices, that's called the disconnected component as in the graph. So think of our world is a graph basically in mathematical terms. And so if we have, let's say, the road, physical road connecting to those cities, so that can be called as edges. Now when you go to the Google map and when you try to find the shortest distance between the two cities, and you also try to put some filters that you want to avoid tolls, you want to avoid specific type of roads. So how does that happen? So now, if you know about the Dijkstra's algorithm, it tries to derive the shortest path distance. Now, in the maths, now you can, if you use that formula and if you give this graph as an input to that formula, you can, so let's see if you can see my uh, cursor. So if I take this city, like this is one vertex of vertex, and if you take this is a destination, so as you can see, there are different paths reaching to that destination. It goes from here also, it goes from on the right side also. So how do you define the shortest path distance? So for that, you have Dijkstra's algorithm, and that algorithm uh, has been derived with the pure mathematics. But now think about the other errors or uncertainty I said, because I said that maths is a logic of certainty and statistic is a logic of uncertainty. So using maths, you can use the Dijkstra's algorithm to find out the shortest distance between two vertices in the graph. But think about the traffic. What if certain path, if the path is very short between the 2 points, but it has maximum traffic? Think about the if the road condition is bad. So what happens in that condition? How do we know that we have the shortest distance, or we can take the minimum time to reach that destination? So in that scenario, the statistics applies that when you see the Google Maps, when you use Google Maps, it takes all the inputs through your phone, and it derives the density over that place, it derives the congestion, and then it tries to find out the new route that you can get um, in less time. So that's where the mathematics and statistics overlap each other. So this is a very great example where you can tally your all the properties, and how Google would have uh, measured the shortest distance, and how they would have used all those properties. So this is a great example. I would say you can Google out their properties and how they are utilized in the Google Maps application. And the next example I always give is Facebook. So as you can see that you have friend list, then you have mutual friends, then you have suggestions, and then you have and Facebook also shows that how many mutual friends you have between any two persons. So how does that happen? So this is example of one graph where we have different people and they got connected to each other, and you see this is nothing but a graph, and all those vertex means the people, the person, and they are connected to each other, they called, and that relationship is called as friend. So now this is Alisa and this Anna. So they have this Artem as a mutual friends. So you see how they are connected to each other, and the suggestion you see on the Facebook that it shows you might know this person, you might know this person. So how does it define? So there they use the statistical models to predict that you might know this person. Sometimes it happens that out of 10 suggestion, you know the 6 people very well, but the other 3 person maybe you don't know. But that's how they predict, and they get better at it. So they ask you that, hey, whether do you know this person or not on the Facebook. And if you don't know the person and you say, hey, I don't know this person, then they acquire that data, they again redefine their model, they again try to accurate their result. So let's see, for the first time they showed you the list of 10 friends, and they show you that these are the 10 people you might know based on their this graph theory and their statistical models. So first time it might happen that you only know the 4 people out of 10, and maybe you don't know the 6 other people. But when you tell the Facebook that, hey, I don't know the 6 people, so what it will do is We'll try to get that input again. It will try to process that data based on their statistical model. They'll try to get those models better. Then again, next time when they will present you the list of 10 people, you will see that out of 10 you almost know 9 out of 10. So how does that happen? Because it gathers the data, it analyzes that the data very well, it tries to give you result. And once they know about the inaccuracy, they again redefine their model and again try to get better at it. So these are some more applications of mathematics in computer science. So you see, I'm not sure how many are familiar with the algorithm analysis. So what does that mean is for every algorithm, so for, okay, let me give you one example. So let's see you have, um, if you have to a destination and you have to, let's say, determine the shortest distance. So you might have different algorithms. So what this mean by algorithms is nothing but number of steps. So let's see if you have to go to college, if that's your problem, then you have to follow steps like take out your vehicle, start your vehicle, follow the road, follow the signal, then go to the college parking, and then park your vehicle, and reach the destination. So that's called number of steps, and that's called the algorithm to find out the result or to find out the destination. So in order to measure that algorithm, it has certain units. So like the vehicle has a speed or distance. So it has time complexity and space complexity. So what does that mean? Like they measure how much faster your algorithm is and how much memory you need. So for that use the recurrence relationship from that is mathematical concept. And again, if you heard about the graph theory, of course, and binary search tree. So in the data structure, we use that a lot. And in the cryptography, we use the number theory. So when you do payment in any of the shop, you swipe the card. So what it happens, like how does it authenticate that card, and how does that user is authorized to make that payment. So behind the scene, the cryptography is being used. So if you heard about the private cryptography and public key, so to calculate that and the match between the two parties, and then they verify the two parties and they allow to make the payment and authenticates that user. So in that, the number theory is getting used. So I think we reached to the end of our session though. So I would like to talk about the career paths for the mathematicians and the statistician. So in the marketing, uh, so you have to do a lot of experiments for the evaluating the new product and conduct the focus groups, and you have to conduct the sample surveys to gauge the customer opinions about that. So let's see, if you open a school or open a college, then you have to do marketing for your college. But to get a requirement, you always have to go to the ex customers. So let's see the students and the people around that area. You have to go, you have to know what kind of education they're interested in, what kind of subject they're interested in, and based on that you try to make some model, and you try to present that these are the subjects we need to implement here in our school. Or let's say you have any car showroom that you need to know what kind of cars you have to have there. So for that you collect certain data out of it, and then if it goes wrong based on your previous experiences or data, then again you try to get better at your surveys or your model. So in the engineering, whether it is a software engineering, we always design any product. We try to taste that product, we deploy that product, and we release that product to the customer. So in the testing phase, it always happens that we come across the different inaccuracy and errors. Then what happens in that case? That we have to go back to our models and we have to put some parameters into it that will improve the quality of that product. So that is a scope for as a statistician and mathematician in the engineering field. And in the survey methods I already explained. In the pharmacology also you have to implement the quantitative methods to ensure the validity and accuracy. As you can see, in every field, there are two terms uh, are occurring often: the validity, accuracy, errors. So whenever you see those models, they use the statistical models to get better at it. And in order to get better at the statistics, it is always better that you get training in the pure mathematics, because find out the logic with uncertainty, you always have to know first the logic of the certainty. So as you try to get better at the data or get better at the results, you have to have the training for the pure mathematics, because you have to know the how to utilize those formulas to find out that certainty and get better at the accuracy. And in the education also, you can implement those models to assess the teacher effectiveness and how. So for instance, this in the COVID pandemics, everyone is thinking about reopening the schools. So there should be some number of steps and that have to be followed, and then we try to measure the results out of it. If so, so what we do is, like, first 2 weeks we try to follow certain model, and after that we get some results out of it, and we think that okay, out of 10 strategies, these 2 or 3 strategies fail. So we try to get better at it, and that's what I'm trying to explain the role of the statistical models. Um, and yeah, in the consulting, you're trying to solve the new and unique problems for a client in agriculture. You have the chemical pesticides. So what extent you have to use so that you can achieve your goals with respect to the crop management. That's what you do. That's what you apply statistics and mathematics in the agriculture. So there are 4 recommendations from my side. So if you are interested in the technology world or in the software engineering, I would suggest you to learn the Python or R programming languages. So you can actually write your statistical models in that, uh, and they can be utilized by the different people. So whether it is a linear regression analysis or any other your models. So so basically, in order to people to use your solution, it is always better for you to know the Python and all R language. And the the rest of the recommendations are common. Design your goals. Um, Try to find out what are your short-term goals and long-term goals, and take actions to achieve your goals. So you should always be knowing that why you are learning something and why what you are learning. So if you're learning statistics, mathematics, you should know what is the career path for your domain, whether you want to pursue your career in the research, business, or any economical stuff, or any software engineer. And once you take the action, just follow the discipline and just repeat it. So with that, I would like to open a channel for a question and answer. So what's the time?
Okay, if there are any questions from the participants, you are requested to raise your hand so that you will be allowed to interact with Mr. Hasbe, or even you can put your questions in the chat box.
Yeah.
The session is open for question and answers. Please put up your questions in the chat box or raise your hand, then we'll allow you to interact with the speaker.
Hello, Swapnil.
Yeah.
Hello,
Yes. Yes, I can hear you.
I am Dr. Umang. I just say one thing. Can you suggest some projects for statistics and mathematics students, which may
Yeah, that's
be depend upon this pandemic situation?
yeah. So that's actually great question. I would say like my last slide in the recommendation I suggested for students to learn the R language or Python language. So I would say start with the let's see Python tutorial and try to code or try to develop one simple program. As I'm aware of that, I think we are already implementing the C or C language or C++ in our college. So I would say that take any Python language, and if you have, let's see, the how to find out this area of the square. So let's take that problem statement and you try to implement that in your any of language, whether it is a C or the Python language. So uh, if I give this any side of the square, so it should derive the area of that square. So that should you should I would suggest you should start from developing the simple formulas or problems in the statistics. So I know that in the linear regression or there are some complex formulas in the statistics and mathematics also. So I would say first start from the finding out the area of the square. Then we have formulas like a square plus b square or is equal to c square. So try to develop those simple programs and make it usable for everyone. So we don't need to calculate on the paper that what's the value of this, right? So so that's what I was talking that try to take any simple formula or the program and try to develop in any programming languages. So that should be your first project.
Thank you.
Go to the Python tutorial, learn about what is variable and what is data structure, and then take a simple problem in your mathematics or statistics. I know those most of the industry use the language Python and R for defining or implementing those statistical models. So where when you just give any input to that, it will just calculate based on their formulas and give you the answer. So learn the Python, I would say.
Okay, thank you.
Swapnil,
Yeah.
hello, Swapnil.
Yeah. Yes,
Um, I have one question.
yeah.
The same question is put into the chat box. Suppose that we have allowed some project to the students. The projects may be from mathematics and statistics. Are you ready to work as a mentor for our few students if they communicate to you through Zoom or WebEx?
Yeah, definitely. It would be an opportunity for me to help the students because I understand that when I was in 11, 12, after 3, 4 years, we always feel that I should have some direction when I was in 11, 12. And I feel that the most of the student where they lack is the direction. They don't know where to go. They don't know why we are learning that. So I'll be very happy to help with deciding those guidelines and what could be the useful for our college. As I can see that when I came to here at the University of Texas at Dallas, and the nature of the syllabus was different than what I have learned in our Indian college, and it was more on application based, and the exam paper used to be for only 1 hour and some of the subjective and objective. So definitely we can create some projects as part of our syllabus or the grading system. So let's see, we can allocate the 50% to the theoretical all our papers and 30% to the projects. And one thing we can also we should also follow that we should encourage all the students to create their own projects, like whatever it may be. Just try to think of something, and whatever you have understood or whatever you have learned, so create some simple projects. So that actually shows that you have gained the application side of your any concept, or you know how to apply those things into your practical life. So that's
Uh,
a very good suggestion, and
okay,
I
okay,
think
thank you. One more question I have.
yeah,
Uh,
please.
so many students from the physics department, as well as from the electronics and chemistry, they correlate their project with the industry. But
Mhm.
there is no very good opportunity for the mathematics and statistics student to correlate their project with the industry. How we have to fill that gap? Students from the mathematics and statistics, they have
Mhm.
correlate their project with the industry, and industries are not giving a chance to work with them for the mathematics and statistical students. So
Mhm.
how we communicate to them, because that project is very helpful to the industry, and
Yeah,
that is a very big problem in our area. So how we
correct.
have to correlate that?
Yeah, that's a very good question, and I would say that's the question we should actually start with. So so exact problem I was trying to, and I'm glad that you brought that question to me. That what happens is we try very hard to get the 90% of the marks and 95% of the marks, right? And when we go to the interview, we realize that whatever we have learned, the industry doesn't want that. And so one of the thing I would suggest that first get better at your communication skill, because if you go to any industry, in order to tell them what is the problem and what is the resolution that problem, you first need to articulate well with them. If you are very good at the technical side, but you cannot communicate what is your problem, so because of that your knowledge becomes useless, I would say. Or you know, if you have, let's see, your knowledge at a 10 level, so you can only communicate with them your 2 3 side of whatever the knowledge, or 30% of your knowledge. So first thing I would say communication, and second thing I would say, if you if you have mathematics and statistic background, you should learn the programming language. That should be, I would say, mandatory. And if you learn the programming language, your many doors will be open for you. Even if you go to the Pune and if you give them resume, and if you mention that you can actually write the statistics models in the Python, this language, so you'll be seeing the multiple opportunities there. So first thing is get communication skill, and second thing I would say learn the language. So
Okay,
that,
very good, very good. Thank you, thank you.
thank you.
I have one more question. Please allow
Yeah,
me.
please.
Uh,
Yeah, please.
Suppose that just you have defined that statistics is related to the uncertainty, and mathematics is the part of this certainty in your own
Definition. Yeah.
language. But see that today's world is the world of the artificial intelligence, physiologic neural network, and so many people are working with the physiologic as well as the artificial neural network,
Yeah.
and these very advanced topics, these can't keep away mathematics from that physiologic and the artificial neural networks.
Right.
But students are not taking very much interest into the mathematics and statistics. Then
Mhm.
how they will learn the artificial intelligence? Because today's world is totally focusing on the artificial intelligence. So what is your suggestion to the students, how they should took any interest into the mathematics and statistics?
Yeah. So usually what happens is the people who are actually in the artificial intelligence or the machine learning, so they are, I would say, most of them are the research oriented or PhD holder people, right? So they basically define the models. But if you have knowledge of both statistics and the programming language, so you know that how to wrap your knowledge and how you can deliver your knowledge to someone, right? So that's where I'm saying that if you have only the mathematics and statistics knowledge, so you have only one word, that is you can be teacher or you can pursue the PhD, right? But if you know the programming language, if you know certain visualization tools, if you know some tools which are used in, let's see, the stock market, right? So how do we visualize those things, those graphs? How do we predict those? So if you know the technology, then in the other domains like economy, business, education, on the client service side, so then you have the opportunities. So I would say you have to get equipped with the technology, then you will see the multiple opportunities. If you have just knowledge of mathematics and or the statistics, then you will be limited to the research area, or you have to be a teacher. But if you're not interested in that, you have to get equipped yourself with the technology so you can present your knowledge. So as I explained that in the software industry, when you have Facebook, or let's see self-driving car, which is an example of artificial intelligence, where it tries to sense the data and tries to define the objects surrounding you. The same thing applies there. So if you know statistics and the language, then you can be part of that Tesla team. You can be part of that Facebook company, right? So if you want to go into the marketing, if you have the knowledge of the statistics, then they would have different tools. Then you can learn that tool, and then you can apply your knowledge, whatever you have, and then you can work for the marketing company, and then you can suggest their committee that, hey, these are the points we actually need to take into consideration in order to promote your products. People are concerned about this factor. When you see any product, so people define the multiple parameter for each product. So for car, they expect certain things, that it should be mileage efficient, it should have sunroof, right? So how does that come? It comes from the analysis, and then they try to define the statistical models out of it. And sometimes it turns out that after 5 years, the demand gets changed. Maybe the people used to have the sedan cars, they now preferring the SUV cars. So then what happens is they have to get better at their model. So these people, the statistician, uh, having their mind, so they can apply their knowledge to help their solve problems. So the bottom line is we have to resolve the problem. So how can you use your knowledge to resolve the problem? So you have to learn those things. So communication, I would say that's the most important, because that will actually help you to land into the opportunities. Because people look for uh, the companies look for the people who can communicate well with your knowledge, so that they can get benefited. So that's the key, the communication, and I would say the technology in terms of learn programming language. That's a mandatory key, and I see that many of the colleges here, they have this R language or Python language. They made that language mandatory, even though they are fundamental level, but that actually helped them to get into the companies. And from the college side, what we can do is we can approach their companies, and we can ask for the requirements. Like we can ask one simple question: what are the skills that you require in order to get our students into your company? Then they can come up with the skills that we need students to get better at communication skills. We want to, so we can ask them, like, give us the simple sample projects that are, if our students do it, then they can directly land into the company. So to answer to your question, so that's these are the things we need to do to fill up the gaps between the whatever the education and the job opportunities. So get the requirements from their companies, and make your syllabus aligning with their requirements. So when they get to the job market, they won't be surprised. They won't be shocked that this is something different, that I have learned something else and they are asking something else. So this gap we can fill by asking them a requirements, by asking them what do you guys expect, and train our students with aligning with those goals. So I hope that's the answer to your
Okay,
question.
okay. Thank you, thank you. Very good answer.
Yeah.
Okay, next,
So
next.
yeah, next question I see from Pradnay Yadav is this Python software is free of cost? Yes, Python is an open source programming language. Just Google out Python tutorial, you'll get all the information, and you will also get the instruction to set up the that language on your editor. So yes, just Google it out. It is just three, four keys away. Just type Python tutorial, you'll get all the details. Next.
We have Syed Afroz who wants to ask you a question. He has raised his hand. Mr. Syed Afroz, you can unmute yourself and ask your question.
Hello, good morning, sir.
Yeah, good morning.
Sir, as you said that conversion of the formulas into Python language, so I have done some of the formulas like basic algebraic formulas, and I'm trying for the some of the binomial theorem formulas and statistics formulas. So, sir, as you said, we can make it useful for everyone. So, on which platform we can do such things, sir? Because on the GIT hub, I can only find many CSC students or I don't find many mathematicians or statisticians searching for things like this.
Yeah. So what I would say, you should actually you can connect to the software industry for that. So if you have sample programs, you should actually get your all programs. Have you heard about the GitHub tool?
Yes, sir. I have heard about the GitHub tool.
Yeah. So that's called repository where you can collect all your work into the one place. So get your work into the GitHub tool. So where when you go to the any company interview, and if you have your GitHub link on your resume, and just tell them to see my project, so then they can ask you the question about it, like how did you derive, what's the um, uh, uh, how can you measure those algorithm or those your formula, how your program is efficient to derive the results. So for instance, if you tell the same problem to different people, they can come up with their different approaches and they will write the different programs. So for instance, let's see, if your program takes 2 minutes and some other person takes 1 minute, so that means that algorithm is faster than that. So you should be in a position to explain those things to the interviewer. So to answer to your question is, I would say make your work public, and if you apply to any software industry, it will be helpful for you.
No, I am not applying for any. I'm just a student of undergraduate second year, sir, presently.
Yeah.
So I was just
Okay.
practicing like thing I did.
Focusing on what?
No, I'm not applying for any job at present. I'm just an undergraduate second year student. So I was just learning the Python language. So to do the different things from the place frame where I am learning the Python language, he suggested me to do the things like that.
Yeah,
But
yeah.
didn't
I,
showed any platform to make it public or something like that.
I would say like GitHub is one of the way to make it public. Otherwise, I mean, I don't know such a like particular platform for where the mathematician, uh, uh,
Yeah,
get
such things.
together,
The same
get
thing,
to,
sir.
yeah.
Same,
What? Pardon?
same thing that on the GitHub only we can find many persons related to the computer science field or artificial intelligence field, but we don't have
Yeah.
mathematicians or statistician people or physicists who are finding
I
for something like Python.
I see. Yeah, yeah. That's what I said. As I mean, I'm not sure like what are the mathematician groups. I mean, I'm more aligning with the software industry, so I know. But what I can suggest you that keep, I think you're doing great work, and I would say like get those all the projects into GitHub repository, and I'm sure that it will help you in landing the opportunities, and also you'll get into the jobs if you have I mean this kind of work at this stage. It's really great. But regarding the groups and the platforms, um, I would say just try to find out the different places. I mean, as a mathematician, I think you can try to find out the Facebook groups, and maybe you can then find out the platforms. I don't have much information on that. I mean, the specific platform related to mathematicians.
Thank you, sir.
Yeah, thank you. Thanks for your question. What I see is cloud computing related to maths or stat. Okay, so cloud computing where we actually use cloud technology on demand. So it's cloud computing includes all other technologies. So I think your question the is this related to math? It's not related to maths. I mean, if you have knowledge of mathematics or statistics, it will be useful. Uh, if you are working for the cloud computing, it will be useful in certain area. It is not like it is related to maths or stat. So second question I have, so now trending is studies in machine learning and artificial intelligence. So it is useful for mathematics aspirants for getting job in industry. Definitely, I would say. Okay, so I will just read out the question. So Asavri Satpute is asking that um, for mathematics aspirants for getting job in industry uh, in into the machine learning and artificial intelligence, how much it is helpful. It is very helpful. I mean, I would say the next 10 or 20 years will be more focused on the artificial intelligence and machine learning. So as a fundamental step for you guys or you students, you need to get some learning about the R, any programming language, whether it is R or Python language. Get better at implementing whatever you have learned in statistics into the programming language, and those are the fundamental steps in order to get into the machine learning and artificial intelligence. So first we crawl, then we stand up, and then we run. So that should be your fundamental step. So now, okay, what's the question? What will be the current situation regarding R and Python in industry? Which language should learn first, or both are equally important? Uh, so both language actually are used depending on their company's requirement. But I would say as a first step, learn any of uh, the language, whether it is R or Python. There is no such important languages. Whatever, if you feel that, if you think that R language is easy for you or Python is easy for you, just start with any of the language. No biases on that. Can you please suggest a good book which deals with application of mathematics and statistics? I would say my whole session my whole session was about encouraging you or motivating you so that you know that what you're learning and why you are learning. So I don't think you need to read the book for application in mathematics and statistics, but I would say instead of that, learn Python language. Somebody is asking what are the sites to learn Python language and R language. There are multiple sites available on the Google. You can just type Python tutorial or R language tutorial. So you can use Google for that. You can use YouTube videos for that. And yeah, that's it. I don't have any specific site, or I don't recommend any specific site, because I think that it depends on the person. Some people find the videos are more useful. Some people find the Google is more useful for them. They just don't want to spend much time on video. So it depends on you how do you want to learn it. But just type the Python tutorial, you'll get multiple links and just find out their structure, how they structure their course for beginners. Start from the beginners. You can start just Python for beginners, and you can select the tutorial what you want. What is difference between the data scientist and data engineer and data analyst? Yeah, it is pretty much so data scientists, they are uh, basically define the models, and data engineer work with the more on data. So they are pretty much similar, but they have specific roles, and it will take time to define the specific difference between them. But all they care about the data, try to get insights from that data and define the models, different models for that. Can you? Okay, I'll try to read what is the future situation about machine learning. Machine learning is already there, and first you have to know the programming language for that. Obviously, the future will be about artificial intelligence and machine learning. So don't worry about that. Just think about how can you learn programming language and how can you utilize your statistics knowledge into it. What is that? The MSc Tech is better than MSc Maths, but still some aspirant don't get job in industry. Yeah. So that question, I can tell you what the steps you need to follow. In order to get job, you first need to know what is required in the job. So that's what I was telling. That don't get disappointed or don't be pessimistic that whatever we learn we don't get job. Don't do that. Just take one step at a time. Try to find out what the industry wants, then try to take first step. So the steps I told you, which eventually land you into the opportunities and into the job. So first you try to learn the programming language. That's I'll stick with that. Coursera is also good for online learning, Python related. Yes, there are different platforms for that. Coursera, Udemy, plural site, but I think you need to pay some money to get their courses. But instead of that, for fundamental knowledge, you can use Google and YouTube videos for now. When you want to get in advanced knowledge into that, then you can go into Coursera and Udemy platforms. Can we learn Python and R at free of cost? Yes, you can learn Python and R language at free of cost. It just multiple keys away. Just type Python R tutorials. You should get the multiple results. It is of course free of cost. If you want to get the courses on the uh, particular platform, then only you have to pay for their courses. But lot of information available on the internet. Okay. Spoken tutorials also offers Python R. Okay, that's great. Some people are telling that uh, where you can get the courses. Just follow the simple step. Get to the internet, type R Python tutorial, and get the fundamental knowledge about it. That's it. That would be the result of my session, I would say. If even 10% of you do that, I will be very happy because I've been gone through all those stages. I know that we get education and go to the market, then we realize that whatever we have learned is not getting used. So one and also get better at the communication skill. Okay, the question is nowadays industry are require experienced person in machine learning. Please suggest me for fresher they are seeking. Okay, that's what I've been saying, that don't think of machine learning and artificial intelligence for now. Don't think of that. Take one step, take one simple step at one time. learn the Python language, try to implement the simple programs into that Python language. That's it. You don't need to think about machine learning. As a fresher, nobody will ask you regarding this machine learning and artificial intelligence. Yes, you can have theoretical knowledge, but as far as the practical knowledge goes, you need to know the implement. You need to know the language and how to implement your model. So I think that's it. Thank you very much for listening me, and thanks for your all question. Uh, so I think we are good to close this session. Thank
Yeah,
you.
thank you, Mr. Swapnil Asbe, for your excellent deliberation on the application of maths and science and stats in our lives. We appreciate the fact that right from Facebook to Google Maps to agricultural field management and making online payments, numbers and algorithms rule. Thank you for giving us your valuable time all the way from USA. I'm sure a lot of algorithm must have gone into making this overseas interaction possible. We also appreciate your answering all the questions of the participants and providing them with valuable knowledge about the career opportunities ahead in mathematics and science, statistics. On behalf of ICIS Satara, we thank you once again and we look forward to more such interactions, especially with you in the role of mentor for our students. Thank you. Now we'll go for the next session. We have with us Dr. S.V. Bhalekar from the School of Mathematics, University of Hyderabad. Sir will be talking about the Wolfram Cloud, which is an ultimate computation system, which is now making the cloud computing, it is allowing the mathematicians to do their work on cloud computing directly on the web browser. So I request Dr. Bhalekar to begin with his lecture on utilizing Wolfram Cloud in learning mathematics.
Hello, coordinators, am I audible?
Yes, sir.
Okay. Good morning, all. I'm using Wolfram Mathematica software for last 12 years in my research. While solving differential equations, nonlinear differential equations, we need computer languages or softwares. There are some topics in mathematics research where you cannot avoid the use of mathematical softwares. There are two types of mathematical softwares. Some softwares are free, that is open source softwares like Scilab, and others are commercial softwares like Mathematica, Maple, and MATLAB. While teaching mathematics, I realized that some topics can be explained better using mathematical softwares. So I started using Scilab in my classroom. Scilab is good software, but still in the course of dynamical systems, I found that I should use Mathematica because it is simple. The commands in Mathematica are simpler and we can have wide applications. Since Mathematica is commercial, I was unable to use in computer lab. I mean, the software is quite costly and not all students can use Mathematica. Last year, when I was trying to get solution for this problem, I found that Mathematica can be used freely using Wolfram Cloud. Wolfram Cloud is available as a web page as well as mobile app, Android app, and it is free to use. Since students can use this software on their mobile, there is no any issue of lab infrastructure also. So in this lecture, I will demonstrate how to use this app. So I have provided a link to download this app and how to install. Now let me share the screen. When you install the software, the app all from cloud on your Android mobile, then you have to log in. After login, you will find this page. When you click the menus, there is create new notebook. Okay. Now you will find some menus like new cell. When you click new cell, there are different options. Let us use Wolfram language input. And then you can start typing. So very basic thing is computation like 2 plus 3. To run this command, you can
I'm
find.
sorry to disturb you, sir.
Yes.
Here, sir, kindly disable the annotation, because I think while using the screen, some annotations are coming up from the participant side. So you can disable annotation by participants from your side.
Okay. Disable.
Yeah, okay, thank you. So you may continue.
Okay. Now you can find spiky icon. When you click spiky icon, you will find the output of this command. Okay. Now let us see some basic things in this Wolfram Mathematica, or we can say Wolfram Cloud. Now I will use Mathematica instead of Wolfram Cloud because Cloud is taking more time and I want to explain so many things. So the platform is different, but commands will be similar. Okay. The first thing is defining functions in Mathematica. So the syntax is use any letter or word you want, then use square bracket for arguments of function. For example, we want to write f of x equal to x square. So x underscore equal to x raised to 2. Now remember that we have to use square brackets for arguments and underscore should be followed after each variable. When we run, you can find output, and now we can evaluate this function at different points, say f of 2.4 and then run. Okay. So this is basic command for defining one variable function in Mathematica. Of course, we can have more than one variables. For example, we can have function z, say z of xy. So we use z x underscore comma y underscore equal to, and now we can have our function. For example, we want to use sine of x square minus e raised to y. Remember that there are inbuilt functions in Mathematica like trigonometric functions, exponential, and so on. Everywhere you have to remember that the first letter should start with capital. Okay, so sine S should be capital, and then we run, and we can have values of z at different points. Okay, so this is the way of defining functions. Now, next important thing is plotting functions. We have Mathematica commands plot. So P should be capital. When you start typing commands, you will have suggestions by Mathematica. Okay, so plot 3D plus and so on. Okay, there are so many Mathematica functions. You can have help regarding such command also. So when you click this, you will find more details about such command. Okay. So let us plot our function. So we want to plot f of x in the range of our choice, say x from 0 to 10. Okay, now what is syntax of plot command? Plot P should be capital, first thing. Then there should be square bracket. In that, first thing should be function. Okay, here we have defined f of x, so we are writing, or we can have any other function. Then it should be followed by comma. Next thing is curly bracket. It is nothing but a list in Mathematica, and this list should have three members. First member is independent variable we are using in function f. Second entry is lower limit, and third entry is upper limit. Okay, so we are plotting function f of x in the range 0 to 10. Variable is x. Okay, let us plot another function, say plot. Let us take function x square minus 1, and we take range x from, say, minus 10 to 10. Okay, you can see this parabola. Okay. Next important thing is plotting several curves at a time, and we can compare. Okay. So we want to plot two functions, say sin x and cos x. S should be capital, comma, cos x, and V. Okay, so syntax is the first entry should be here. Our first entry is two functions. Okay, so these two functions should be in a list. Okay, so in a curly bracket we have to write first function comma second function. Okay, so we can have three functions, four functions, etc. Okay, So there is no any issue. For example, we can have e raised to minus x also. Okay, so these three functions in a single window. Okay. Now, important question is how to recognize that which color is assigned to which curve. Okay. So here Mathematica is assigning different colors to different curves itself. But we can assign these things ourselves. So Mathematica has options. Okay, so in plot command we have different options. So after this we put comma and we use the option plot style. Okay, so P should be capital, S should be capital, plot style, then arrow, again a list, for example. Okay, so we assign colors of our choice. Again, these are inbuilt things. First letter should be capital, say brown, red, and blue. Okay. Now first color is assigned to first function, that is brown is assigned to sin x, red color is assigned to cos x, and blue color is assigned to exponential of x. Okay. There are so many options in plot. For example, we can have axis labels. Okay, so option is axis label, and we can write say x, y. Okay, you can find that now axes are labeled. Okay, let us plot another function, that is z. You know that z is two variable function x and y. So we cannot use the plot. The plot of z will be a surface, and we have to use plot 3D command, plot 3D. So plot 3D. Then again syntax is very similar. We have to write function z of xy. Then we have two independent variables x and y. We have to assign values, say x from -1 to 1 and y from 0 to 1, for example, and then we can run. Okay, so this is surface. When we click this surface and drag, we can view this surface from all the sides. This is very useful while studying some concepts as well as in research. Of course, we can have several curves in plot 3D. We can have options in plot 3D like axis labels, different colors to different surfaces, etc. These are similar to the command plot. Now we see another thing in plotting, that is list plot. In some cases, we have discrete data. Okay, instead of continuous data, we may have discrete data. So before that, we should learn lists. Okay. In Mathematica, list can be defined directly. For example, L1 equal to, we can have, okay. In Mathematica, we don't have to declare any variable like C language. L1 equal to, we can write 1, 2.3, 9, -4, 10, etc. Okay, and we have to run this. So this L1 is a list. Another way is, if we have formula, then we can use the command table. For example, L2 equal to table, and we want L2 as list of numbers. For example, I square plus 1, and I values are from 1 to 10. Okay, so here we write I is list variable, so our function is I square plus 1, and I is running from say 0 to 10. Okay, so syntax is table, T should be capital, then square bracket, then write your function. There should be some variable, say I. Then second thing is a list where we assign the starting and ending values. Okay, so I comma 0 comma 10. If we run, we find that this is a list of the numbers of the form I square plus 1. First entry is I equal to 0, so we have 1. Second entry is I equal to 1, so 1 plus 1. Then third entry is I is 2, so 2 square, that is 4 plus 1, 5, and so on up to I equal to 10. Okay. Now we can plot such list using list plot. So list plot L1, we can find that the points of L1 are 1, 2.3, 9, minus 4, and 10. Here, the horizontal axis values are integers 1, 2, 3, etc. Means the first entry in the list is 1, it is assigned to 1. Second entry is 2.3, it is assigned to 2. Third entry is minus 4, so this value is assigned to 4, and so on. Okay. Of course, we can join these points using the command list line plot. Okay, so all these points are joined. Suppose we don't want these horizontal axis points as 1, 2, 3, etc. Then we can assign these points using two-dimensional list. Okay, so instead we can have another list, say L3 equal to, which is two-dimensional list. We have to use two curly brackets. Say first entry is say 0, comma 1.1. So we are defining ordered pairs. Second is say 0.5, and it is minus 0.2. Third is 0.8 and 0.4. Okay, so this is two-dimensional list. If we plot this list using the command list plot, then we can find that this list is plotted, so each member is ordered pair. So when we have first entry 0, that means x-axis value is 0, y-axis value is 1.1. Next is x-axis value is 0.5 and y-axis value is minus 0.2, and so on. We can join these points using list line plot. Okay. We know that some functions are parametric functions. So there is independent variable, say t, and we have to plot that function. So x is x of t, y is y of t, and we have to sketch x and y. Okay, y versus x. So let us use parametric plot. Mathematica command is parametric plot. So here the first entry should be a list of parametric functions. Say, let us consider x is sin t and y is cos t. Or let us take sin 2t and y is cos t, and we take t from 0 to 10. Okay, so this is required curve. Okay. We can sketch difficult curves using Mathematica, which we cannot sketch by using pen and paper. Let us move to some basic calculus. We can find derivative using Mathematica. The function is capital D. So capital D, we have to write our function, say x raised to 5. Then comma x means we are assigning the variable. Okay. So this command is capital D is Mathematica function which provides derivative. In the square bracket, first entry is our function, comma, second entry is variable name. Okay. If our function is of 2 or more variables, then this function will provide partial derivative. Okay. So say y into x raised to 5. Remember that this y into x, there should be space between these two variables either, or we can use star. Okay. So y into x raised to 5, we are differentiating with respect to x. So this is partial derivative. We can differentiate with respect to y also. We can have second order derivative. Say differentiation of this with respect to x 2 times. Okay. Now integration. The command is integrate. We write our function, say x with respect to say x square with respect to x. This is indefinite integral. Now suppose we want to place limiting values. So integrating, say sine of x from x equal to 0 to pi. So pi is pi, capital P, small I. Okay. So this is definite integral. We can have multiple integrals also. Okay, so all the higher things can be found using help menu. Some more basic functions are sum. Okay. So this function is used to sum, to find sum of such entries. For example, sum I square, I is from 1 to n. Okay, of course we can have n. Okay, so answer is 1 upon 6, n into 1 plus n into 1 plus 2n. Now let us move to solving differential equations using Mathematica. So syntax is D solve, D should be capital, S should also be capital, D solve. Then syntax is first entry should be a differential equation. For example, we consider simple differential equation y dash is equal to minus y. So syntax is y dash of x equal to y of x. So remember that we have to use equal to sign 2 times. Okay, while solving equations, we have to use equal to sign 2 times. If we use only at once, then it is assignment. Okay, so y dash of x equal to y of x. Second entry is what is dependent variable in this differential equation, and third entry is what is independent variable, and run the command. Okay, so this is your answer. Solution is e raised to x into c1. C1 is arbitrary constant. We know that solution of this differential equation is c1 e raised to x or c e raised to x. We can assign initial values also. So for example, we don't want general solution. Instead, we want particular solution satisfying certain initial condition. So what we have to do? We have to use again a list. So first entry is a list instead of a equation. Okay, in this list, we have to write differential equation and initial condition, say y of 0 equal to 1.1. Okay, and then run. So our answer is now 1.1 into e raised to x. Okay, so this is particular solution. We can solve non-linear differential equations using Mathematica, and that is power of Mathematica. We can solve very difficult equations also. If it is possible to provide exact solution, then Mathematica will provide exact solution. Okay, so this is y dash is equal to y square. This is non-linear differential equation, and Mathematica is providing exact solution. In some cases, we cannot have exact solution. In that case, we use ND solve. N means numerical. Okay, ND solve. Okay, so let us solve one system of differential equation which is non-linear. Okay, so we use ND solve. Syntax is very similar. First entry should be list containing differential equations and initial values. Okay, let us consider independent variable as t. Our equation is x dash of t equal to 10 y of t minus x of t. This is first differential equation in the system. Second differential equation is y dash equal to 28x minus y minus x z. So minus x of t into z of t. Third equation is z dash equal to minus 8 by 3 Let me check the equation. Z dash equal to minus 8 by 3 Z plus xy. We assign initial conditions also. Say x of 0 equal to 10, y of 0 equal to 0, and z of 0 equal to 10 again. So this is list of differential equations and initial conditions. Second entry is list of dependent variables. Here we have x, y, and z. And third entry is independent variable. Since we on numerical solution, we have to assign the range for independent variables. Say t from 0 to 60. And we give some name to this command. Name is of our choice. Okay. This is solved. You can see that interpolating function. Okay. So our answer is in the form of interpolating function. We can sketch these curves. Okay. So how to sketch these curves? We have to use this name, that is S. Okay. Anything you can assign here. Okay. So plot x of t. Remember the command slash dot s. Slash dot means replace all. Okay. We are sketching x of t from the command whose name is x, and t is between 0 and 60. Okay. So this is sketch. This system is very famous. It is called as Lorentz system. Now let us sketch x, y, z as a parametric curve. Okay. So let us sketch parametric plot 3D. Okay. We are going to sketch x, y, and z in 3D space. So x of t, y of t, and z of t slash dot s t from 0 to 60. Okay. So this is solution curve in 3 dimension. Okay. So this is famous Lorentz system. Okay. It is very difficult. I mean, using pen and paper, you cannot find solution of this differential equation, and you cannot sketch also. Okay. So we have to use softwares. Now let us see some basic algebra. We can have various polynomial operations in Mathematica. For example, we can expand polynomial, we can factor polynomial, and so on. Okay, so I will show you some demonstrations. First command is expand. Suppose we want to expand the polynomial, which is given by 2 plus 4x square bracket square multiplied by x minus 1 cube. Okay, so simply use command expand, E should be capital, and write your function. Okay, so this is expansion of this polynomial. We can factor polynomials using the command factor. Okay, the commands are user friendly. You don't have to remember the commands in mathematics. Factor, say x raised to 10 minus 1. Let us. Okay, so these are factors. We can use simplify for some expressions. Simplify. Okay, so let us see examples in help menu. Okay, so for example, simplify this expression. We can see that it is simply 1 upon 1 plus x cubed. So such polynomial operations can be found in Mathematica. Of course, there are so many things, but I'm explaining only few. Once you learn how to use Mathematica, then you can use help menu. There are demonstrations available online. Okay, so you can also use ready to use programs using Wolfram website, demonstrations website. Next thing is solving algebraic equations. Okay, so first simple example is solve quadratic equation. So command is solve. We have to write our equation. Say ax square plus bx plus c. Okay, equal to 0. Note that Mathematica is symbolic computation software. That means we can use A, B, C, etc. Okay, so such equations can be solved in Scilab also, but we cannot write A, B, and C. We have to assign values to such parameters. In Mathematica, we don't have to assign values to parameters in general. Okay, so we don't have to mention also. We don't have to declare variables. Okay. So solve ax square plus bx plus c equal to 0. Here we have to mention the variable x. Okay, the solution is well known, minus b plus minus square root b square minus 4ac divided by 2. Okay, we can solve system of equations also. So let us solve a system. So system should be written as a list. So first equation is, let us see linear system. Of course, we can have non-linear system also. X plus 2y plus 3z equal to 4. Second equation in this system is 3x plus 4y plus 5z equal to say 6, and last equation in this system is 7x plus 7y plus 8z equal to 9. So this is first entry, which is list of equations. Second entry should be variables. Here variables are x, y, and z. Okay. So here is solution. X is 0, y is minus 1, and z is 2. Okay. We can solve non-linear systems also. If exact solution is available, solve command is useful. If it is not possible, then we can use n stands for nonlinear. Okay, so n solve. Let us see examples in help menu. Okay, so here are some examples of nonlinear equations. N solve, first list is x square plus y cube equal to 1. Second equation is 2x plus 3y equal to 4. Okay, so first equation is nonlinear and we have solutions. There are some complex solutions also. Okay, so Mathematica can be used to find such solutions also. Now we can have vectors and matrices in Mathematica. Vectors are nothing but list. Okay, so if we want vector say v1 equal to say 1 0 minus 1, this is treated as vector. Okay, second vector is say v2 equal to 2.3 minus 1.2 and 4. Okay, so we have defined these two vectors. Now we can find we can have different operations on such vectors. For example, we can find norm of vector, say norm of v1. Okay, Euclidean norm. That means square root of summation of each entry, square of each entry. We can have matrix in Mathematica. Matrix is two-dimensional array. Okay, so let us define A as a matrix. So we have to use list, which is two-dimensional. So each row is given in one list. Okay, so first row, for example, is 1, minus 2, 4. Okay, so first row is one list, comma. Comma means we are going to next row, say minus 2, 0, 3, and third row is 4.1, 2.2, and 5. Okay, if you are using Mathematica software, then this can be viewed as matrix also. In app also you can view this as a matrix. The command is matrix form. Matrix form, M and F should be capital. Matrix form capital A. When you run, you will see it as a usual matrix. Okay. Now what are matrix operations? They can have determinant of matrix. So det is command for determinant, det of A. So this is determinant. We can find inverse of matrix. Command is inverse. Okay, commands are user friendly. Let us call this matrix as a B. Say B equal to inverse of A. Now we want to check whether this is correct. Okay, so if this is inverse, then product of A and B should be identity matrix. Okay, now let us see. For matrix product, we have to use dot. That is same as full stop dot. Okay, so A dot B. Okay, you can see that this is numerical computation. I'm using matrix form percent. Percent means last result, previous result. Okay. So this entry is minus 2.7 into 10 raised to minus 17, which is almost 0. Okay. So since the computation is numerical, there is small error, but it is negligible. Okay. So this is identity matrix. Next thing, we can find eigenvalues of matrix. So command is again simple. It is eigenvalues of A. These are eigenvalues. Of course, we can find eigenvectors, eigensystem, etc. Okay, so these are eigenvectors. We can have characteristic polynomial. Command is same, but C and P should be capital. Characteristic polynomial, square bracket, your matrix. There is another thing you have to mention, that is variable which you want to use in that polynomial, say x. So this is characteristic polynomial of matrix A. Okay. These are basic things in linear algebra. Now let us move to basic programming in mathematics. We can use for loop in Mathematica. Syntax is for f should be capital. In square bracket, there are different entries. First entry should be starting value of variable. Then next thing should be test, and then increment, and last thing is body. For example, simple command is for I equal to 0. This is starting value. Then test, say I less than 10. We have to run this loop for this I less than 10. Third thing is increment. The command is same as C language, I plus plus, and then body. You can use anything. Say, let us print I raised to 3 minus I square plus 2. Okay. So this is your answer. Okay, for different values of I. So syntax is simple. There is while loop and do loop also. These are having similar syntax. Next thing is conditional statement, if else. Again, we should have capital I. If, then syntax is, first thing is condition, and then we have different options. Okay, so this is flexible thing. Let us consider, say, condition. First we take some variable, say A. We assign value for A as A equal to 3. Okay, semicolon. Now condition is if A is less than 10, then, so comma should be there. We have to write something. Okay, so this is simple program. Of course, we can have in all programs. So the purpose is to introduce Mathematica commands only. So print so we want to print some string. So for that we need to use quotation marks. Okay, so let us write down some message, say less than 10. Okay, and now run. We know that this condition is true, so it is printing this string. Okay, now let us see another thing. Next conditional statement is, suppose I'm writing if A is less than or A is greater than, say, 4. We know that this condition is false. A is not greater than 4. Okay, so this if is flexible thing. We can have two things. Okay, so we can place comma and write another thing. If this condition is true, first thing is evaluated, otherwise second thing. Okay, so we write two strings. The first string is if this condition is true, then we write greater than 4. If this is false, then we write string less than 4. Okay, now this condition is false, so second thing is evaluated. Okay, less than 4. Okay, so this is if else. Now there is very nice structure in Mathematica that is called as manipulate, which is graphical user interface in Mathematica, which is very useful in research as well as teaching. So let me show you one example and then I will explain the syntax. Say the problem is I want to sketch a sine ax plus b, the curve sine ax plus b for different values of a and b. Let us take only one parameter, say sine x plus b for different values of b. And I want to analyze the effect of b on this graph. Okay, so in such cases, manipulate command is very useful. Okay, so manipulate. What I want to do, I want to plot. Okay, so plot. The function is sine x plus b. B is having some values, and now I want to plot this function in the range, say x from -10 to 10. And now, so this selected part is plot thing. Okay, that I already have explained. Now we have to assign the range for this b. Okay, so here we have to put comma and then write b, which is variable of manipulate, and then assign values. Say b is from 0 to say 6. Okay, and now run. So this is interactive object in Mathematica. You can see the scroll button. If you are using your mobile app, then just put your finger at this button and move your finger. Okay, you can find things. Okay, so here the values of b. What we are plotting sine x plus b. That means here we are changing b, and we can see the effect of b on this graph. We can see that when b is 0, we get routine sine x function. Okay, now what happens if we change b? Okay, so when we change b, the graph is moving upward. Okay, so at value b equal to 1, it is touching x-axis, and when we increase value of b, then it will be above x-axis completely. Okay, so this is interactive object. Here there is button of play. We can play this function for different values of b, etc. Okay, so this is very useful function. Of course, we can have number of such parameters. Okay, so let us consider two parameters. Say instead of b, we take b1 and b. Sine b1 plus x plus b2, for example. Now we have two such parameters, right? b1 between say 0 and 6, and let us assign some value for b2 also. B2 between 0 to 10, for example. Okay. Now we have two things. We can study the effect of B1 and B2 at a time. What happens if we change B1? You can see that movement is horizontal. Okay. So there are physical meanings. When we change B2, movement is vertical. Okay. Actually, this manipulate is very involved thing, and one lecture should be spent for this manipulate. Okay. So I suggest you to check help menu and demonstrations with manipulate. You will surely find interesting things. Okay. I think this is what I wanted to explain. All these were basic things. Now session is open for discussions. Thank you.
Thank you, sir, for guiding the participants on the usage of Mathematica platform and Wolfram Cloud. Participants are requested to put forward their questions in the chat box, or they may raise their hand so that we may allow you to interact with the speaker. Yes, Pooja Jadhav, you may unmute your mic and interact with Dr. Bhalekar. Pooja Jadhav, you may unmute your mic and put up your question. You have raised your hand. Okay. Shrutika Patil, you may unmute your mic and pose your question to Dr. Bhalekar.
There are some questions in chat box also. So, shall I
Yes,
take
sir,
these
you may.
questions?
Yes, sir, you may. Please,
Okay.
sir.
Sir, is this free? I already have mentioned that Mathematica is commercial software, but for learning and research, we can use it freely. Okay, so this all from cloud is completely free. You can download and install on your mobile. You can use the same ID and password on website also, and you can run the same command as Mathematica. So I can say that it is free. If you are a teacher, you can use this in your class to explain so many things effectively. Surely all your students will have Android mobile, and students always love to use mobile phones. Okay, so if you ask them to install this software on mobiles, then it is very interesting class. Sir, this software free or not? How to get this? I already have shared one video on the group regarding the download and installation. So the link will again be shared, or you can check my YouTube channel also. You just have to check Google, type all from cloud, or you can use your Android mobile Play Store, search all from cloud, download the software. First thing is to register, and within 2 or 3 days, you will receive one email from Olfram, and then your account will get activated. You can start using. How to plot complete compile variable function? I don't know what is COMPLE. There is some mistake. I have shown two variable functions. Plotting is 3D. Okay, so plot 3D is used to plot function with more than one variable. Of course, software is not free, but app is free. Can we have some list of coding for different mathematical formula in Wolfram in PDF file so that we can practice first then use? Yes, you can have ready to use commands. You just have to go to demonstrations, Wolfram demonstrations. Visit the Wolfram demonstrations website where you can find different ready to use commands. Otherwise, you can use help command. In that, similar commands are there. You can just copy and paste and practice. Okay. So using Mathematica is not difficult thing. Is Wolfram Cloud and Mathematica different? Technically, these two things are same, but platforms are different. Wolfram Mathematica uh, runs your programs on your computer only. Cloud means you are sending your commands to Wolfram website. Your programs will be run there. Okay.
Sir, hi.
Hello.
Related to this, I want to ask one question. Are there any similarities in Mathematica and R software?
Actually, I am not familiar with R software, but commands in R can be used in Mathematica. Okay, just search help menu R commands in Mathematica. Okay, if you are familiar with R, then this can be used. Further, there are so many commands in statistics, so many functions of statistics which are available in Mathematica. Okay, I have not covered that part, but this was only basic presentation. Okay, once you are familiar with Mathematica, then you can go to help menu. You can find so many things. Okay, Mathematica is used in industry, research also. Okay, so whatever you want, probably you will find there. In case you have more doubts, I am sharing my email ID in chat box. So you can always email me. I'm planning to put more detailed lectures on YouTube also. So email is Sachin Bhalekar at uohyd.ac.in. So within this short period, my aim was just to introduce this platform. So important thing is it is free to use. It can be used in teaching as well as in research. And it is not difficult to handle.
Thank you, sir. Participants, you may take note of the email address shared by Dr. Bhalekar, and you can pose your questions to him directly, and he will definitely revert back to you. With this, we come to the next session, which is the feedback session. We would appreciate feedbacks from the participants. The feedback link for the manual, which you will be filling up online, is being shared with you. But as of now, if some participants want to give their feedbacks about today's international webinar on technological trends in mathematics and statistics, you may please raise your hands. So maybe we will allow you to express your views on this online platform. If some participants want to express their views verbally, please raise your hands. We will allow you to speak. Yes, Miss Sonali Nursery, are you willing to speak and give your views about the international webinar? Okay, so participants, you will fill up the feedback forms on the online link. Now, may I request the co-convener of this international webinar on technological trends in mathematics and statistics, organized jointly by the Department of Mathematics and Statistics, Dr. H.P. Umap, to deliver the vote of thanks. Dr. H.P. Umap.
Honorable speakers and participants, this is very good experience to listen the views of international and national resource persons through this online international webinar on technological trends in mathematics and statistics. Both the resource persons are given valuable guidance on the fundamentals and as well as applications of mathematics and statistics in real life situations and especially in software industries. First of all, I am thankful to Mr. Swapnil Hasbe, innovation software developer in USA, for his valuable guidance. And here I would like to mention that we are teaching Python and R software in our syllabus of statistics for UG and PG. I am also thankful to Dr. Sachin Kumar Bhalekar sir, Associate Professor, School of Mathematics and Statistics, University of Hyderabad, for sharing the information regarding utilizing Wolfram Cloud in learning mathematics using Mathematica software. Thank you, sir. I am also thankful to our principal, president of this international webinar, Dr. B.T. Jadhav sir, for his kind support and encouragement to organize this international webinar. I am also thankful to Vice Principal Dr. V.Y. Deshpande sir, Convener Dr. D.R. Haspe sir, Secretary Mr. S.S. Nalaude sir, all faculties of Department of Mathematics and Department of Statistics, and at last but not the least, I am thankful to all participants, especially participated from out of India, out of Maharashtra. Especially thanks to some renowned persons in mathematics such as Dr. M.S. Chaudhary sir. He is listening carefully the views of both resource persons. Once again, thank you all. Thank you very much.
Thank you, sir. With this, we come to the end of the international webinar. There are a few things which the participants need to take note of. The e-certificates will be delivered to you by mail within 5 days, but you have to fill the feedback on the link provided to you. So with this, we come to the end, and with the permission of the chair, I declare that the seminar is over. Thank you one and all. End. So end the meeting.
Meeting.
No.